Congruence of triangles. Important theorems. Theorem of 30 degree, 60 degree, 90 degree triangle. Hypotenuse-side theorem. Perpendicular bisector of a segment. Angle bisector and locus. Theorem of 30, 60, 90 degree triangle. If the angles of triangles are of measure 30, 60, 90 degree, then the side opposite to the angle of 30 degree is half the hypotenuse. In triangle ABC, measure of angle A is equal to 30 degree. Measure of angle B is equal to 90 degree and measure of angle C is equal to 60 degree. Now we have to prove side BC opposite to 30 degree angle is half of hypotenuse. For that, we construct AD is equal to AC and BD is equal to BC. Now in triangle ABC and triangle ABD, we have a congruent angle pair and two pairs of congruent sides. Hence, triangle ABC is congruent to triangle ABD. Therefore, again we get segment AC congruent to segment AD and angle C congruent to angle D. Hence, angle C is equal to angle D is equal to 60 degree. Now in triangle ADC, angle C is equal to angle D is equal to 60 degree and angle DAC is also 60 degree. Hence, triangle ADC is equilateral triangle. Therefore, AC is equal to DC, half of AC is equal to half of DC. But half of DC is BC. Therefore, BC is equal to half AC. Where AC is hypotenuse and BC is side opposite to angle 30 degree. In this way, we proved in 30, 60, 90 degree triangle, side opposite to the angle of 30 degree is half the hypotenuse. Hypotenuse-side theorem. Two right-angle triangles are congruent if the hypotenuse and a side of one triangle are congruent to the hypotenuse and corresponding side of the other triangle. Let ABC and PQR are two right-angle triangles. Their hypotenuse AC and PR are congruent and also sides AB and PQ are congruent. In construction, take a point S on ray RQ such that segment BC congruent to segment QS and join PS. In the proof, we first prove triangle ABC and triangle PQS is congruent with the help of given. From the congruency, we can see that segment AC also congruent to segment PR. Therefore, triangle PRS becomes isosceles triangle and hence we can see that angle R congruent to angle S. Now we have three sufficient conditions. Two congruent pairs of angles and one congruent pair of side. To prove triangle PQR and triangle PQS are congruent triangles. We have proved triangle ABC and triangle PQS are congruent and now we have proved triangle PQR and triangle PQS are congruent too. Therefore, by 1 and 2, triangle ABC and triangle PQR are also congruent. Perpendicular bisector of a segment. The line is said to be a perpendicular bisector of a given segment if it is perpendicular to the segment and passes through this midpoint. You know the procedure to bisect any line segment. AB is a segment and L is a perpendicular bisector of it. Let us take a point P anywhere on this perpendicular bisector L. Then the distance of point P from point A is equal to the distance of point P from point B. It means the point P is equidistant from the endpoints of the segment AB. This is known as perpendicular bisector theorem. Angle bisector. This is an angle ABC. We know the procedure to bisect any angle. Therefore, BX is a bisector of an ABC. Now take a point P on this bisector. Draw perpendicular from side BA to P and then from side BC to P. We find that P is at equidistant from side BA and from side BC. That is, PQ is equal to PR. This fact is stated in the form of a theorem known as angle bisector theorem. If a point is on the angle bisector of an angle, then it is equidistant from the sides of the angle, or its converse as. If the point in the plane of an angle is equidistant from the sides of the angle, then it lies on the angle bisector. Locus. We have seen that the point on the bisector is equidistant from the endpoints of the segment. The set of all points on the bisector satisfying same condition is called locus. Similarly, the set of all points on the bisector of an angle is a locus. Locus is the set of points which satisfy certain condition is known as locus. For example, in Marathi, locus is referred as bindu patha, that is, path of point. When a point moves according to the given condition, certain path is traced. That path is known as locus. For example, if point P rotate around O by keeping same distance between them, we get a circle. Therefore, circle is also a locus of points equidistant from point O. Summary. Dear students, in this subtopic we have learnt theorem of 30, 60, 90 degree triangle, hypotenuse-side theorem, perpendicular bisector of a segment, angle bisector and locus. So that is all in this topic. Maths is fun. So keep learning.